Okay, hello. Happy Friday, everyone. All right, uh, okay, good, happy Friday. Good Friday evening, everyone. Right, so today, let us continue on our chapter year 7 revision. Okay, last week we stopped here. Let me finish this. Okay, let me finish these questions. This chapter, which is chapter 1, and we shall go into the next one. All right, so let's go to page 9. Okay, I hope you have your notes ready. So by now, I mean, this is week 2 already. You should have received your notes by now. Your physical copy. All right, so next, let's look at number 10. Okay, this is your muscle. Last week we did talk about this. This is your antagonistic muscle. When one muscle contracts, the other muscle will relax. So like I said, if this muscle shorten, if my bicep shorten, my tricep needs to lengthen to go longer. This one go shorter, so I will pull my arm up. If my tricep contract become shorter and my bicep relax, my arm will become longer. So you see, okay, antagonistic, they work in opposite way. So the diagram shows the muscles in a person's leg. Okay, so on the diagram, label these bones. Okay, so where's the femur? Okay, the femur is the biggest bone in your body. The femur is here. Okay, your femur, your 大腿骨, your upper thigh bone. So people just call it thigh bone lah. Okay, the scientific name for it is femur. Okay, so pelvis is your hip. Okay, your butt. This one, okay, your hip bone. And then tibia is the bone in front here. Your calf bone, lower leg bone. 你的小腿骨. That's the tibia. Okay, so this one you don't know how to don't know how to label is okay lah, because this one is not too common in exam, because this thing is very there's a lot of things to memorize here. Okay, so they won't ask something so specific lah. So what kind of joint is the knee joint? Okay, your knee can only go up and down. Your knee cannot go left and right. So this is what we call a hinge joint. Okay, hinge joint. Your hip joint or your shoulder joint is called a ball and socket joint, because your shoulder you can move 360. Your elbow you can only move up down. Okay, so anyway, see on the diagram, label a ball and socket joint. So your ball and socket joint is here. Okay, so this is your ball and socket joint. So this is why when you rotate your legs, it's moving at the hip joint, right? You're standing, you can just rotate your leg to the back, rotate to the front, just like your shoulder. Okay, we call it a ball and socket joint. Very flexible. Okay, so D, look carefully at the diagram. What will happen at the knee joint when muscle A contracts? Okay, so A contracts, you just have to draw here. Okay, if you forget, then you just imagine your A becomes shorter. Your A pulls. A is like a string, it pulls. When A pulls, what happens? This thing will go up. Right? When this thing shortens, B will relax, this thing will go up. So when A contract, you can say the leg bends. Okay, the leg bends. It's like bending your arm. Okay, so next E, what will happen at the knee joint when muscle B contracts? So now it's the other way. When B contracts, this thing becomes shorter, this thing pulls. When this muscle pull, this leg will open, go forward, will kick forward. So what happens at the knee joint? Okay, when a joint opens, we call it extend. Okay, it extends. So the opening of a joint, okay, opening is called extension. The closing of a joint is called flexion. Okay, flexion. This is why when you are showing off your muscle, it's called flexing lah. Flex is to show off lah. So flex is when you close your joint. So extension, flexion. Okay, so F, which of this pair of muscles are antagonistic pair? Underline the two correct answer. So these two, A and B, they're antagonistic. They're opposite of each other. Okay, they work opposite of each other. So C and D is the same. So A, B, and C, D. Okay, they're antagonistic. Means when one contracts, the other relax, and the other way around. Okay, next 11. Now this is your knee joint. Remember, this is your ligament to connect bone to bone. This is your ligament, and to connect bone to muscle, this is your tendon. We mentioned this last week already. So what is X? Okay, where is X? I think X is this one. Okay, please draw here. So X is your cartilage. Okay, sorry, there's something here. Okay, I missed the X already. Why is X important? Okay, like I said, what's the function of that white color stuff here? This is the cushion, remember? Okay, it cushions. Okay, it cushions the joint. Okay, or you want to say absorb shock. Okay, for the joint. And also, okay, that means if you jump down from a high ground, your knee is going to absorb the shock. That's why don't try not to jump from a high ground. If you can. I mean, if you're an athlete, then different story lah. But as a normal person, you shouldn't jump from high ground because it's very stressful on the knee. Okay, not even climbing stairs. Okay, do you know what's the stupidest exercise to do? Is by climbing stairs. Yes, climbing stairs is very healthy. It makes your heart healthier, but it is the stupidest exercise because it stresses your knee a lot. Okay, so don't climb stairs is one of the exercise. I don't understand what's the point. Okay, why might as well you go and walk. Okay, walk or cycle. It's best. It's less stress on the joint. Even swimming is good for the joint. Climbing stairs is not. Okay, yeah, unless you don't have a choice, lah. Okay, it really hurts your knee. So there are slippery liquid around X. What is the liquid called? Okay, so here there's a oil-like liquid in the middle. It lubricates the joint. What is the liquid called? That's a synovial fluid. Okay, synovial fluid. So this fluid will decrease as you age. Okay, when you turn 50, 60, the fluid will be so little that you start to brush, your joint will start to rub against each other. So that's the edge, the age where you start to get, painful joint and so on. Okay, part of getting old. So D, footballers have high risk of developing disease. Why? When they have this disease, their movement becomes painful as their X wear away and the fluid around X disappears. So what is Y? Y is arthritis. Okay, arthritis is the swelling of your joint. Okay, we call it 关节炎 in Mandarin. 知道什么是关节炎吗？你的阿公阿妈应该是有的，就是你的关节不是很好的arthritis Okay, here's the thing, guys. A little bit of extra info for you. Whenever you see the word itis, itis means swelling. Okay, swelling. That's why when you have dermatitis, that's the swelling of the skin. 皮肤红肿 dermatitis. When you have painful stomach because you didn't eat, it's called gastritis. Not gastric, it's called gastritis. The swelling of your stomach. What else do you have? Tonsillitis. Okay, when your tonsils are swollen when you're sick. Okay, tonsillitis. Appendicitis, when your appendix is swollen, okay, then you need to go for surgery. That's the swelling of your appendix. All right, so next diagram below shows the bending arm. So what is X, Y, and Z? Okay, X is the bicep muscle. Y is the tricep muscle. Okay, Z is the tendon. Okay, because it connects muscle to bone. That's a tendon. Okay, when you eat chicken, sometimes you will eat this part. It's very hard to chew. So X and Y are antagonistic muscle. What does it mean? Okay, they work opposite, or you can say in opposite motion from each other. Okay, or you can say when one, you can say when X contracts, Y relaxes, and vice versa. Okay, vice versa 就是相反啦。Okay, what is X? Oh, bicep. Sorry, my handwriting is terrible. Sorry. For bicep, BICEP. Okay, do you know why is this muscle called bicep? Because bi means two. They have two muscles here. Okay, you have two lines of muscles here. And why do they call it tricep? Because as the name says, tri means three. You have three muscles here. So they call it tricep. Okay, so this is like a guy's biggest dream lah. Okay, girl will also look at bicep one. So if as a guy you have a very big bicep, then you know people will look at you. People will look at your arm. Wow, you're very manly. So this is why people train this muscle. So C, explain how humans bend their arm involving X and Y. So how do they bend? So I think I gave the answer here already. X contracts, okay, Y relaxes. Okay, so what's the function of Z? What's the function of this tendon? Tendon is to connect muscle to bone. Okay, if you lift too heavy of a weight, if you lift too heavy, this tendon can break. Okay, no joke. So please don't go and do something stupid. Go and lift the heaviest weight that you have never lifted before. You must snap this thing in half. Okay, and if you do, then it's surgery. There's nothing for them to fix it. You have to go for surgery. They will use needle and thread to sew this thing back. Okay, so in conclusion, don't be stupid. Don't lift something heavier than you can lift. All right, so anyway, that's it for this chapter. Okay, really easy stuff. Okay, I didn't finish this last week now. Okay, so today let's go into unit 7. Okay, chapter 7, which is our acid and alkaline. Okay, this is a very important chapter. So we are only doing the remaining important chapters. The rest, if I have time next time, revise with you lah. So acid and alkaline, this is a very important chapter. For sure, we'll ask an exam. The good thing about this is it's very easy to understand. Okay, acid and alkaline, they are opposite of each other. It's like black and white. Okay, boys and girls. So acid and alkaline, so they are on the other end. So let's look at each of them. What are they? So in Mandarin, acid is 酸 alkaline is 碱酸性碱性. Okay, acidic and alkaline. So I'm sure you know what is this. So 7.1, acid and alkaline. Let's look at acid first. What is an acid? You know what is an acid. Your stomach has acid. Lemon has acid. Oranges have acid. Pineapples have acid. Anything sour is acid. Okay, your car battery has acid. You know that? Do you know what's your car battery? Your dad needs that to start his car. So after 2-3 years of using, if one day your dad cannot start his car, that means the car battery is broken already because the acid inside is not good. Now they need to change to a new battery. Okay, you know that boxy looking heavy thing inside the engine bay. That's the battery lah. All right, so let's look at acid. An acid is a solution. Okay, do you remember what is a solution? You learned this year. So what is a solution? When you take a cup of water, you take salt, you put it in, you stir, you get salt water. Salt water is a solution. Okay, so a solid dissolved in a solvent. Remember what is this? Solid is the solute. Okay, solvent is the liquid. You see, salt dissolves in water to form salt solution. So acid is a solution. That means it has water inside. So of course, acid tastes sour. Lemon contains citric acid. Okay, citric acid. In fact, all that's why we call it citrus fruit. Okay, citrus fruit, 酸酸的水果就叫 citrus fruit. Like your lime, lemon, I think orange is one of it too. Pineapple, any of the sour fruit. Okay, because there's acid inside. All right. And some acids are corrosive and need to be stored in container with a hazard symbol. What is corrosive? This is the first characteristic I need to know. Okay, sour, corrosive. Corrosive means they can eat away stuff. Okay, for example, if you put acid on your hand, on your skin, if it is strong enough, it will eat away your skin and you will feel painful. This is why you don't simply play with acid. Okay, in fact, do you know how strong your stomach acid is? Your stomach acid is hydrochloric acid. Remember, you learned this year. So your stomach acid is so strong, okay, it's so strong, you can swallow a piece of aluminum foil. You know aluminum foil, when you make, when you want to bake something, you use aluminum foil. You can swallow one piece of aluminum foil, your stomach has no problem digesting it away. Okay, you won't see aluminum foil in your shit because that thing will be dissolved away by the stomach acid. That's how strong the stomach acid is. Okay, so don't play around acid. Okay, and you don't taste acid. Yeah, sure, acid tastes sour, but you don't taste strong acid unless you have a death wish or something. Okay, and needs to be stored in a container with a hazard symbol. So usually they will put this symbol here. Okay, can you see? This is the corrosive symbol. So it means it will eat away your stuff. Now that's why acid rain will corrode your building. So that's the meaning of corrosive. So acid originate from two sources. Okay, so we have two types of acid here. You have organic acid. When you see the word organic, okay, I'm sure this is your mom's favorite word, right? When she buys veggie, when she see veggie, she's like, eh. And when they say organic veggie, she's like, oh my god, must buy. Okay, so what does it mean by organic? Organic means it comes from living things. Okay, it comes from living thing. So if the acid is from living thing, then it's an organic acid. So organic food is a stupid myth. Okay, all food is organic. Okay, would you eat non-living stuff? Veggie is a living thing, chicken is a living thing. Okay, so I don't understand why do you have organic chicken and inorganic chicken? All chicken is organic. Okay, a chicken is not made from stone. All right, so you have your organic acid, and of course, if it is from a non-living thing, you have your inorganic acid. Usually inorganic acid, they are stronger, much stronger. Can you see these three acids here? Sulfuric acid, nitric acid, hydrochloric acid. These three, they are inorganic. Okay, they are inorganic. Organic acid, usually we don't use it in the lab because it's too weak. Okay, like your vinegar is an organic acid because it comes from living thing. Okay, so it's not really useful. I mean, for cooking, okay lah. But if you want to do experiment, vinegar is too weak. 醋，你知道醋哦，醋是一个很弱的 acid 来的。Okay, so as you can see here, organic acids are generally weaker acids compared to inorganic acid. So they are not so good to use. So examples, organic acid, you have your citric acid. Where do you see this? Like I said just now, your citrus fruit. Okay, tartaric acid, this is from your grape. Okay, this thing tastes a little bit bitter. A little bit bitter. This is why if you drink wine, you know wine, right? 红酒, 葡萄酒. So when you drink wine, especially red wine, you can taste the bitterness. One thing is because of the alcohol. Second thing is because of the tartaric acid. It has that sour taste in your mouth. Okay, red wine lah. Okay, yes, they are bitter, but after the bitter, there's a little bit of sourness to it. That's the tartaric acid. And then acetic acid is a vinegar. Ascorbic acid is a vitamin C. It also comes from citrus fruit. Lactic acid comes from your milk. Okay, when you leave your milk outside without fridge, after a few hours, your milk will turn sour. That's the lactic acid. And when you exercise for very long, you feel very sore. 肌肉酸痛，有试过吗？你打球打太久，你的肌肉会酸啊。That sour feeling, it's lactic acid. You produce too much lactic acid in your stomach, in your muscle. That's why your muscle feels painful. Okay, so what do? Rest off. Let the acid go away. Okay, so inorganic acid, the strong ones, hydrochloric, nitric, and sulfuric. Hydrochloric, what do we use it for? To clean metals. Nitric acid, we use it in fertilizer, dyes. You can also use it to make explosive. Nitric acid can be used to make TNT and dynamite. Okay, you know what's this, right? TNT is explosive. It's bomb, basically. All right, and then of course, sulfuric acid is used in your paint, fertilizer, and your battery electrolyte. Your car battery has sulfuric acid. This is why you should never, 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 if your car battery is broken, you should always recycle it. Don't worry, because when you change new battery, they will take the old one away, they will recycle the thing. Please don't throw this thing in longgang. Okay, please don't throw it in the longgang because you are creating so much pollution. Okay, easy peasy. So this one, Aqua Regia, you can read this yourself. Okay, it's a very interesting story. Okay, you know what? I'm not going to talk about this. Okay, this is for reading pleasure. Okay, so next, let's look at alkali. Okay, alkali is 碱. So alkalines are also a type of solution. They are the counterpart of acid. They are the right opposite of acid. Okay, if acid is white, alkaline is black. Okay, if acid is a girl, then alkaline is a guy. Okay, you get my meaning. So if acid is left, then alkaline is right. So similar to acid, strong alkalines are corrosive. Okay, corrosive. One point I missed here, you can say alkalines are bitter. Okay, acid is sour and corrosive. Alkali is bitter and corrosive. So what's the alkaline? Your soap, your soap, your detergent, anything that is bitter, it's alkaline. All right, so alkalines are used in cleaning product. They feel slippery and soapy. Sorry, these are the Y here. Now, what is soapy? Soapy means slippery lah. When you touch your soap, it has that slippery feeling. That's the meaning of soapy. So let's look at alkaline. The most famous would be your sodium hydroxide and potassium hydroxide. Whenever you see these two things, this is in your soap and detergent. Okay, sodium hydroxide is very good in cleaning, in removing oil. That's why when you have oily face, oily skin, oily hair, oily plates, oily whatever, you use this thing will wash away the oil like effortlessly. But it not only it washes away the normal, okay, since it washes away oil, right? It also washes the oil on your skin. Okay, do you know naturally your skin has oil? 你的皮肤天然就是有油了的。So if you use soap, you're gonna wash it away too. That's why you don't use soap on your face. Do you? I hope you don't wash your face with soap. To wash your face, you need a facial cleanser. Because facial cleanser, they don't put this thing. The thing you use to wash your face, read that. It will say no soap. Because they cannot put this thing. This thing is too strong. If you use this thing to wash, if you use a soap to wash your face is going to be very dry. And when your face is too dry, that's how you get pimple. Okay, so don't use your, I'm sure you're not, okay, everyone knows what's your face cleanser, please don't use soap and wash your face. All right, so calcium hydroxide, this is used to treat water and treat soil. If I have acidic water, for example, acid rain, if I have acidic soil, because of the acid rain, I can put calcium hydroxide to neutralize them. That's a neutralization. Okay, remember what is that? Acid plus alkaline, it will neutralize. They will cancel each other out. So your water and your soil will become neutral because acidic water will kill a lot of living things. Okay, and acidic soil will kill a lot of plants. It's not good. That's why we put calcium hydroxide. Next, ammonia. This is in your pee. Okay, you know when you pee, your pee has that pee smell, right? That's the ammonia smell. So ammonia is used in your fertilizer and your cleaner. So you know those window cleaner, the Mr. Muscle blue color one, you spray on your window and then you just wipe away. That thing has ammonia. The thing actually smells a little bit like pee. Okay, if you have wiped windows before, I mean, sure, it doesn't smell like your pee because that thing has fragrance inside, but it has a little bit of a pee smell because of the ammonia. All right, magnesium hydroxide. This is used in milk of magnesia or your antacid. Basically, this is your gastric medicine. Okay, so gastric is because when you have too much acid in your stomach, so you put some alkaline inside, you neutralize them, and then you will feel more comfortable. You don't feel that gastric pain anymore. Okay, so next, to work with alkaline acid, always wear safety goggles to prevent splashing. If an acid or alkaline is spilled, wash it with plenty of water, dilutes it. So especially if you are using very concentrated acid, the best way you can make it safer is by diluting it by a lot of water. Okay, rinse it with water. Okay, so how do you detect acid and alkaline? Okay, this is our indicator. Okay, this one is very important. Acid and alkaline, they are colorless. So detecting an unknown acid or alkaline by touch or taste can be dangerous. Please don't go and taste acid and alkaline. That is a very stupid thing to do. Would you eat soap? No, you won't. Okay. Would you taste battery acid? Of course you wouldn't. Okay, unless you want to burn your tongue or something. So this is why we use indicator. What is an indicator? Indicator is something that is used to see whether something is acid or alkaline. Okay, how do they do so? They will do so by changing color. You learned this already. So indicator is a chemical that changes color in acid or alkaline. Litmus is the most common indicator. So what is a litmus? Litmus is actually a flower. This is a litmus. So we will use the color from this plant to make something called litmus paper. Okay, 石蕊试纸 litmus paper. So litmus is a type of dye extracted from lichen. Lichen is a type of plant and algae and fungi living together. Okay, so it's a dye, it's a color. Litmus can be used as a solution or absorbed into a paper. So you have litmus solution and you have litmus paper. So they come in liquid form or they come in paper form. So litmus is purple in neutral. Okay, if you put it in water, litmus is not showing you anything. Litmus paper is, it doesn't show you anything. Okay, it's purple. So in acidic, it will turn red. In alkaline, it will turn blue. Now, this is why to test acid, you will use blue litmus paper. In alkaline, you use red litmus paper. This one I need to memorize. Litmus will turn blue to red when it's acidic. It will turn red to blue when it's alkaline. Okay, so what else can you use? If you don't want to use litmus, you can use your red cabbage, black currant, beetroot, hydrangea flower. Have you seen this thing before? Okay, this is a very special flower. When it is acidic, it will be blue. When it is alkaline, it will be pink. So that's your that's why if your garden has this, and if your flower changes color, you know that your soil is changing pH. Your soil is changing whether it's acidic or alkaline. So if your soil is acidic, alkaline, so you will have different colors. This flower in your garden, okay, which makes it very beautiful. Okay, so next let's look at our pH scale. I'm sure you know when we measure acid and alkaline, we use something called pH. So indicator shows us a solution is acidic or alkaline. However, it does not show us the strength of an acid or alkaline. Okay, for example, if you use a very strong acid, okay, and if you use a very weak acid, they both will change blue litmus paper red. So how do you know this is a strong or weak acid? There's no way to tell if you use litmus paper. This is why we use pH scale. Okay, pH scale. So pH scale gives an idea of how strong an acid or alkaline is. Okay, it runs from 0 to 14. Okay, 0 to 14. So 0, the closer to 0, the stronger the acid. The closer to 14, the closer the alkaline is. Okay, I'm sure you learned this before, right? Last year. So 0 is the strongest acid. 14 is the strongest alkaline. All right, so 7 in the middle is neutral. Water is 7. So this is why we use something called universal indicator. So you see, your litmus is a very lame indicator. It only shows 2 colors. Whereas your universal indicator, they show you like 14 types of color. So you will roughly know what pH they are. All right, so a universal indicator measures the pH of an acid or alkaline. So you can also use other indicators. So you have your methyl orange, phenolphthalein. If you want something easy, just use a pH meter. pH meter is the easiest to use. It's a stick. You just put it in, the meter will show, okay, this is pH 7. All right, but last time, when technology wasn't a thing, they need to use this thing. Okay, it's like a piece of paper, and then when you test this, you take this paper and compare to all these colors, see which one is the closest law. So as you can see here, this is very strong acid, dilute hydrochloric acid. Your stomach acid is 1. Our stomach acid is pH 1. Okay, only 1 weaker than 0. That's why if you don't eat, your acid is going to corrode your stomach. That's why you get gastric, okay, gastritis. So make sure you eat. Okay, don't starve yourself. Okay, and then from 3, 4 here, these are all weak acid lah. For example, your lemon juice or your vinegar. Your vinegar is very weak acid, it's only pH 4 or 5. Milk is even weaker. Milk is slightly, ever so slightly acidic. They are pH 6. So your 7 is your water or your salt. Okay, 7 is neutral. Blood is slightly alkaline. In fact, blood is pH 7.4. Your blood is pH 7.4, which is slightly alkaline. Okay, very important. Your blood cannot be acidic. If not, you will die. And then your toothpaste is pH 8. Okay, you're only brushing your teeth. You don't need to go crazy. They only need a slight alkaline thing. And then lime water. What is your lime water? Guys, lime water is not air limau. It's not you go mama, you order limau ice. That is not lime. Lime is a type of stone. You know cement? You know cement? We use cement to build houses, right? Cement is lime. Okay, lime. In Mandarin, it's called 石灰. It's like fuya. You know your plaster ceiling? You know your wall, your paint, it's made from lime. So lime is actually alkaline. Okay, because lime is calcium. Okay, if you use bleach or washing soda, this is pH 11. Please don't drink this, you will die because bleach is pretty freaking strong. In fact, I think bleach is around 12 to 13. Bleach is strong. And oven cleaner. Okay, 14 is oven cleaner. What is an oven cleaner? Don't let this thing touch your skin. Okay, and as the name says, it's an oven cleaner. Usually oven is a very dirty place. It is full of oil, full of grease, because after all you're baking and whatnot. Oven is very dirty. So this oven cleaner is freaking strong. Okay, you only use this if it's really, really oily. So this is pH 14. I mean, if you want to die, if you want to kill yourself, I wouldn't. It would be a slow and painful death. Okay. There are so many less painful ways to commit suicide. I don't understand why people drink bleach. You know, people drink bleach to kill themselves. Yeah, there are cases lah, but I seriously don't understand. I mean, not that you should kill yourself. I mean, come on, if you really feel suicidal, please go and seek for help. But I mean, I don't really get the point of using bleach. Okay, so moving on. Let's go to neutralization. What is neutralization? Neutralization is when you mix acid and alkaline. When you take acid alkaline mix together, they will cancel each other out. Okay, they will cancel each other out. So we know that acid and alkaline, they are chemical counterpart. When an acid mixes with alkaline, they cancel out each other in a chemical reaction called neutralization. Okay, very important, this reaction. So this is what happens. Acid plus alkaline, you get salt and water. Okay, salt and water. So for example, hydrochloric acid, you add sodium hydroxide. Remember, this is a soap. You will get sodium chloride and water. Sodium chloride is the salt you eat. You know, you put salt on in your dish. When your mom cooks, she put salt, right? Sodium chloride is the salt. So sulfuric acid plus potassium hydroxide, you get potassium sulfate and water. This is also a salt. But not all salt can be eaten. This salt you cannot eat one. Okay, the salt we can eat is only this one. It's called edible salt. The rest is not. All right, for example, nitric acid and sodium hydroxide, you get sodium nitrate and water. This salt you cannot eat because this thing will cause cancer. Sodium nitrate is a cancerous salt. Do you know where do you know where they put this? They put this in burger meat. They put this in bacon. They put this in nugget. All kinds of preserved meat, frozen meat. They will put this thing. That's why it causes cancer. Okay, eating burgers, eating eating nuggets, eating bacon or whatever frozen meat sausages. That's why they cause cancer, because this is the salt they add, okay, to preserve the meat. So please, try not to eat so much of this. Okay, so neutralization can be carried out in the lab using a technique called titration. Okay, please highlight this. The experiment is called titration. This is titration. Do not confuse neutralization and titration. They are very different things. Neutralization is the chemical reaction. 那个化学反应叫 neutralization, 中和. The experiment you are doing is called titration. Okay, the method is called titration. When you do titration, inside here is doing neutralization. I hope you get what I'm trying to say. Right, so an acid in a burette is this thing up here. I hope you still remember what a burette is. Okay, a burette slowly added to an alkaline. Okay, you add it here. So how do you know? This thing has no color. Okay, this pink, white, you must say, sir, this one pink. Why is it pink? Because you need to add universal indicator. Okay, universal indicator is added to alkaline to show the process of neutralization. At the beginning, it is purple because at the beginning is alkaline. So as you add more and more acid, this thing will go purple, light purple, blue. When it reaches green, this is where you stop. When you reach green, everything is neutralized, everything is neutral, everyone is happy. They cancel each other already. Please don't add too much. If you add too much, you're going the other way already. You are using too much acid. This thing becomes acidic now. All right, so as acid is slowly added to the flask, the purple solution will change from blue, then green. When a green solution is formed, we know that the acid has cancelled the alkaline. The acid neutralizes the alkaline. So when this thing turns green, that's the end of experiment. That means that thing is like neutral already. You may drink this thing. I mean, I wouldn't, because God knows what's inside there. All right, so let's look at the next one, 7.5, neutralization in action. Where do we use this in daily life? Number one, a bee sting. If a bee stings you, a bee is alkaline. So what do? You put it's acidic. So what do you do? You put alkaline to neutralize it. If you are stung by a bee, take some soap, put it onto the wound, you'll be fine. Okay, but if a wasp stings you, please notice the difference. A wasp is not a bee. Okay, a wasp, the sting is alkaline. You need to use vinegar or acid to neutralize. A bee will not sting you. Okay, do you know this? Bees, okay, can you see this bee? Bee is very cute. Okay, bee, their job is to get honey and to pollinate your flower, to make you have fruits. So bees, they are the good guys. Okay, they are cool. They are very friendly and cool. Unless you go and kacau them, you go and, you know, you being an asshole, go and attack some bee, of course, out of self-defense, they will attack you lah. But wasp is different. Okay, these guys, they are assholes. Please don't mess with them. Okay, you know what I mean. If you go to any place that has wasp, for example, some plantation, these assholes, they are going to hurt you. Even if you don't kacau them, you don't disturb them, wasp will come and disturb you. So don't screw around. These people, they are not joking. So when you see wasp, please run. Okay, for the love of God, please run. Okay, they can kill you. And they will attack in gang. They will ask their gang and come and attack you, and that's how you die. Not even joking. All right, so next, indigestion, when you have too much stomach, too much acid in your stomach. So indigestion is caused by too much acid produced by the stomach. It causes acid reflux. When your hydrochloric acid in your stomach goes up to your heart, to your esophagus here, it feels painful, heartburn. Okay, I'm sure you recognize this brand. Okay, you watch TV or not? Okay, they have this Gaviscon thing, what? If you have this heartburn feeling, then you eat this Gaviscon, it will make your stomach so much better. So that's your medicine. So the acid can be neutralized by using antacid, which is a type of medicine. Antacid contains sodium bicarbonate, which is baking soda that dissolves to form an alkaline. Okay, so these things, if you have gastric problem, I mean you're not unfamiliar with these things. Okay, you'll be eating these things a lot. So here's the thing: if you have gastric problem, this thing doesn't cure your gastric. It only soothes your gastric. 它只是让你的胃痛没有这样痛。What's the real reason for your gastric? You have to find it out. Okay, do you eat on time? Do you eat a lot of spicy food? Or do you have very bad feeding habit? You just don't eat on time. You eat rubbish food all the time. Sometimes you don't eat, you skip meals. Sometimes you just stuff yourself very full. You're playing yo-yo with your stomach like that. Of course, it's going to hurt it. Okay, so gastric, you need to find out what's the real reason. Okay, these things will help. Okay, next, baking. Baking soda or your sodium bicarbonate is added to bread dough. If your mom bakes, you will know what I mean. So this baking soda, it will react with the acid in the dough. Carbon dioxide is produced. When carbon dioxide is produced, it will rise the dough. Okay, that's how your bread rise. So carbon dioxide rise the dough and make the bread airy and fluffy. So the more baking soda you put, the more fluffy your bread is going to be. This is why if you look at bread, there are holes on it. That's because of the carbon dioxide. Okay, so similar concept is used in model volcano or soda acid fire extinguisher. Okay, you know what's a volcano, right? A model volcano, you do the same thing. Okay, next, toothpaste. Now, why do you brush your teeth? Because your mouth has acid. You have bacteria in your mouth. Bacteria is always acidic. Okay, so you eat every day, you have bacteria in your mouth. Okay, so and they feed on the food pieces left in our teeth. So this acidic bacteria is a bad thing. They will corrode your teeth. Okay, bacteria produces acid which can corrode our teeth enamel. Okay, enamel, sorry, it's called enamel. Okay, so it causes decay. So what do? You use toothpaste contain alkaline, it neutralizes the acid. That's why when you brush your teeth, you kill all the bacteria inside and you neutralize all the acid. So your mouth stays fresh. Okay, see, baking soda. That's a toothpaste. Okay, the last one. Neutralizing soil and water. Many industries burn fossil fuel to produce acidic gas. Okay, this acidic gas react with water vapor to form acid rain. Okay, which is not a good thing. Acid rain reduce pH in soil, kill many plants, dissolve mineral in soil, carry them away. Okay, this is called leaching. Leaching will make your soil infertile. Okay, it washes all the mineral away. Mineral is the fertilizer, the 肥料. So if you wash it all away, how can plants grow? They will all die. So what do? So this problem can be reduced by adding slick lime, which is a calcium hydroxide, the one I said just now. Slick lime react with the acid rain, okay, and neutralizes it. It's added using water treatment to reduce water acidity. This is what they do. This is the slick lime. Okay, they put it on the soil, they put it in water to make the thing neutral. Then your water and soil is good to use now. Okay, easy peasy. Yeah, so go and read this yourself. Yeah, I'm going a bit fast here. Next time read this yourself. Okay, so 8. The words below each have something to do with either acid or alkaline. Write each word or group of words in the correct column. So the first one, I'm just going to write 1 and 2. I'm just that lazy. Okay, so citric acid. Now you see the word acid, you know this is number 1. Okay, next, cola. Okay, do you know Coca-Cola? What is this? Do you know, is it acid or alkaline? All types of soft drink is acidic. Okay, it's acidic. That's why when you drink too much soft drink, it's going to corrode your teeth. You know this? If a kid, like a 3-year-old kid, he or she, if they drink Coca-Cola every day, they are going to have tooth decay. Even eating candy is like that because candy is also acidic. This is why they say, okay, I'm not sure whether you heard of this. They say, yeah, Coca-Cola is very bad. You can use Coca-Cola to wash your toilet bowl. You put Coca-Cola into toilet bowl, you can flush it away and your toilet bowl will be clean. God knows what it's doing to our body. Chill, it's okay. Coca-Cola is okay to drink if you don't drink it every day. Coca-Cola is good for washing your toilet bowl because it has acid. It has acid. You put lemon inside, also the same thing one. Okay, you squeeze lemon juice into your toilet bowl also clean one. Does it mean lemon juice is dangerous for you? No, it is not. Okay, water will rust iron also. Does it mean you don't drink water? You see this water so bad, it will corrode iron. It will make iron rust. Wow, then we don't drink water. Okay, then you don't drink water. Okay, this is just a stupid myth. Coca-Cola is fine as long as you brush your teeth and you don't, don't drink it every day. Or you can just drink Coke Zero. You see, mine is Coke Zero. This thing has no sugar. Okay, it is sweet, it has no sugar, it makes everyone happy. Okay, it will not give you diabetes. It will, when you want something sweet, then you want something sweet. Okay, this is like a fake sugar, so it makes you happy, but it doesn't give you health problem. All right, so next, lemon juice. This is acid. Okay, nitric acid. Why so many acid one? Okay, so acid. Sodium hydroxide, that's a soap. Okay, so this is alkaline. Your soap, say soap, same thing. Okay, alkaline. So vinegar is acid. Washing powder, alkaline. Whenever you see washing, for sure it's alkaline. Washing soda, alkaline also. Okay. Anyway, next, let's look at B. Determine whether the statement are true or false. So all acids are dangerous. No, false. Vinegar is not dangerous. You don't hurt someone by splashing vinegar on them. I mean, sure, it will sting, but that's all. Okay, all acid are bitter tasting. No, acid, they are sour, not bitter. So false. Bitter is alkaline. Next, acid have pH value below 7. Yes, true. Okay, 7 being neutral. 0 is acid, 14 is alkaline. Next, number 4, acids turn universal indicator purple. No, it's actually red. Okay, so false. Purple is alkaline. Okay, purple is alkaline. Okay, how do I know this? How do I if I say sir, how do I memorize this? Okay, very easy. For me my mom used to use this dishwasher. Okay, the dish cleaner, the dish soap, when you wash your plate, her bottle was purple. So that's how I remember. Okay, there was this brand from Causeway, it was purple one. Okay, so I just remember it that way. Okay, or you just remember you have a red strawberry and it is very sour. So red is acidic. Okay, so next, alkaline turns universal indicator green. No, okay, it's actually purple. Green is actually neutral. So false. Alkaline is sweet tasting. Well, no, it's bitter. Next, hydrochloric acid is an example of strong acid. Yes, true. Okay, so don't mess with this thing. This thing is already in your stomach. Okay, do you know why you have such strong acid in the stomach? One of the reasons, I think you know this already, is to kill bacteria. If you eat some dirty food, okay, you sit roadside and eat, and you see there's fly everywhere, you don't care, you just eat. Most of the time, you're gonna be fine. Okay, yeah, sure, the food is very dirty, but do you get diarrhea? Sometimes you do, sometimes you don't. Okay, why don't you get diarrhea? Because the acid is protecting you. Okay, so thank your stomach for that. Okay, moving on. Let's go to C. Complete the table below. So hydrochloric. Okay, so we have a lot of words here. Hydrochloric acid in stomach. This guy is pH 1. Yeah, I think I told you this. Very strong acidic. Okay, very strong acid. Smelling salt, ammonia. Okay, this smelling salt. Okay, what is this smelling salt? Okay, let me show you this smelling salt. This is used in okay, there. It's put to your nose to kind of wake you up. Okay, to prevent fainting. Okay, to prevent fainting. If you go to hospital and you are a little bit unconscious, they will actually give you this smelling salt. This thing stings, it's like a strong pee smell. You think of your pee, you know, your pee has a smell, right? This is much stronger than that. So this is called smelling salt. Okay, so this is actually, okay, ammonia is a weak alkaline. Oops, why is it green? Why is it green now? Okay, so this is a weak alkaline. That is a weak alkaline. So weak alkaline is pH 8. Okay, pH 8. pH 13 is a strong alkaline. pH 8 is slightly alkaline. Because neutral is 7, 8 is slightly alkaline. Kitchen cleaner, this is pH 13. That's why if you want to use this thing to clean whatever, please wear a glove. If you have to touch oven cleaner, please wear a glove. If not, you will get very dry and nasty skin. Okay, for obvious reasons. Okay, next, tap water. This is pH 7. Dish soap, the one you use to wash your plate, the one is pH 10. So they are kind of strong, but not too strong. Strong enough to remove oil, but not too strong that it will hurt your skin. But still, if you have to wash your plate for a very long period of time, please wear gloves also. I'm sure if the whole day you have been washing dishes, washing your clothes, washing your dishes, showering, you will feel your fingers it gets very dry. Okay, because it takes away all the healthy oil on the skin. Okay, so color of universal indicator, since this is acid, it will turn red, a strong red. Okay, so this is acid. Oh, sorry, strong acid. It should be strong acid. Okay, smelling salt. This is a weak alkaline. So weak alkaline is roughly blue-green. Okay, because green is neutral, blue-green is slightly alkaline. So this is a weak alkaline. Okay, cancel all this. One. Okay, kitchen cleaner. Our kitchen cleaner is very strong. So this is purple. Okay, purple. So this is a strong alkaline. Next, tap water. This is this should be green. Green here. Oh wait, I think this is blue and green. Sorry. There's no blue green. Okay, so green here. So this is neutral. And the last one, dish soap should be dark blue. Now you see, this is blue because it's weak. Now this is dark blue because it's stronger. The dark blue is a strong alkaline. Not really too strong now. You can say I would say a moderate though. Not really, not to say really strong, but moderately strong. Okay, fine, whatever. So this is the answer. Okay, so moving on. This chapter is very easy. It's always just acid and alkaline. There's only two sides to study. Okay, so number 2. So shows pH value for 4 substance. That's your pH scale. You have 1 here. I should be 0 here. Okay, 0 to 14. Okay, 7 is neutral. So the more here you go is this is acidic. This is alkaline. So this is a weak acid. This is a strong acid. Right, same thing. This is a weak alkaline. This is a strong alkaline. So the higher you go, the stronger alkaline it is. The lower you go, the stronger acid it is. So A, based on the above diagram, compare acidic properties of P and Q. So let's compare P and Q. So like I said, P is strong, Q is weak. So you can say P is a stronger acid than Q. Make sure you compare. That's why I use stronger, weaker, because I need to compare. So alkaline properties of S and T. So same thing. T is a stronger alkaline. So T stronger than this one. Okay, so B, which two substances when mixed together will change the color of universal indicator to green? Okay, how do you change green? Green is neutral. How do you make something neutral? Very easy. If you have a weak acid, you would neutralize with a weak alkaline. Right? Right? If you have a strong acid, you will use a strong alkaline to neutralize it. Please don't use weak acid and strong alkaline because this thing will still be alkaline. Okay, you want them to be in the middle. So weak, you counter with weak. Strong, you counter with strong. So you can either use Q and S, or you can use P and T. Okay, common sense lah. Common sense. If your mouth is pH 6, okay, your mouth is pH 6 because of the bacteria. So when you brush your teeth with toothbrush, toothpaste is pH 8. So 6, 8 will pull to 7. You don't say, oh, this is weak acid, I better use bleach pH 13. You will corrode your mouth, okay, because it's not needed to be so strong. You get what I mean? So weak acid, weak alkaline. And if your stomach is pH 1, so this is why you eat a strong medicine like pH tend to neutralize that thing. Strong acid, strong alkaline. Okay, so next one, figure 1 shows the reaction of blue litmus paper and red litmus paper. So as you can see, the red turns blue, so this is alkaline. This one, blue turns red, so this is acidic. This one also red turns blue, so this is alkali. Okay, I only want you to take note of the one that changes color. Okay, the one that changes color. The one that doesn't change color, don't care. That's not our concern. So when this is originally red, it changes to blue. Red to blue is alkaline. Blue to red is acidic. Red to blue is alkaline. So based on your observation, classify the solution into two groups according to the common characteristic. Okay, so acid and alkaline. Okay, two groups. There's only two groups we learn, right? So state two other characteristics of each group you stated in 2C. So for acid, they can be sour and corrosive. For alkali, they can be bitter and corrosive also. Okay, same thing. That's why I asked you to memorize the characteristic. And you know lah, you know acid is sour lah. This is not really memorizing. So E, in your opinion, why a litmus paper is less suitable to determine the strength of an acid or alkaline? Okay, because it only shows whether an object, not object, whether a solution, sorry, whether a solution is acid or alkali. It does not show pH value. That's why litmus paper is not good. Strong acid and weak acid, same thing. So you don't know which one is strong. Okay, it doesn't show pH value. What we want is pH value, because pH value is like a rating system. We know how good something is. Okay, a 3-mark restaurant, a 3-star restaurant, and a 5-star restaurant, yeah, they are both good, but the 5-star one is much better. Okay, that's why you need a rating system. You don't just say, oh, this thing is good. How good is good? What's the rating? Okay, you get what I mean. All right, so you know what? I think I'm gonna stop here. Okay, our time is up. I will continue with this next week. All right, so if you have the time, you can go and finish this. Okay, there's a lot more to do. Okay, next week I shall finish this with you. Okay, so that's it for today. Hope you have a good Friday. Happy Friday. I will see you next week. Okay, so see you next week. Good night and bye-bye.